body starts from rest, means u is equal to 0. Acceleration given to you as 2 meters per second square. They have asked you how much will be the distance covered in 2 seconds. So have a look at the 4 alphabets S, U, A, T. These all 4 alphabets come in which formula? That is equation number 2. Substituting the values, u is 0, half is 2, t square, t is 2 square, 2 and 2 gets cancelled, therefore the distance is 4 meters. Second question, body starts with initial velocity of 10 meters per second. Similar question, the only difference is here initial velocity is 10, in the previous question it was 0. Everything else is same, distance is asked, time is given, acceleration is given. So we will be using second equation of motion. Substituting the values, this time u is 10, time is 5 plus half. So s is equal to 50 plus 125 upon 2. Solving this further. So the distance traveled is 112.5 meters. In this question, the initial velocity given to u is 30 kilometers per hour. U is equal to 30 kilometers per hour. After 2 seconds, the velocity is 33.6 kilometers per hour. We know that acceleration is v minus u by t. So I am finding v minus u. V minus u will be 33.6 minus 30, that is 3.6 kilometers per hour, and this is not SI unit. So converting this into meters per second. So I got the value of v minus u as 1 meter per second. Now substituting over here, acceleration is 1 and time given to you is 2 seconds. Hence the acceleration is 0.5 meters per second square. Now in the second part of the question, after 2 seconds, again the speed is now 37.2. In this case, initial speed 33.6 kilometers per hour. Again after 2 seconds, final speed is 37.2 kilometers per hour. Therefore, v minus u in this case, if you subtract, you get the same value, 3.6 kilometers per hour, which is nothing but equal to 1 meters per second. Again, if I find the acceleration, I get the same value, that is 0.5 meters per second square. The question asked is find the acceleration. We have found out once, but twice. Why twice? Because they are asking, is the acceleration uniform? Since both the cases we are getting the same value, therefore we can say that acceleration is uniform. A body starts at rest. Initially it is at rest. Acceleration is 2 meters per second square. Calculate the velocity acquired in 5 seconds. Therefore, according to first equation, v is equal to u plus at. Substituting the values, you will get the value of velocity. Acceleration is 2, time is 5. Hence, velocity is 10 meters per second. Now, acceleration. You can use the same formula once again. Sorry, we have to find distance. So, distance is s is equal to ut plus half at square. Substitute the values. Therefore, distance is 25 meters. Bullet is moving with initial velocity of 20 meters per second. Strikes a target and comes to rest. Comes to rest means v is equal to 0. After penetrating a distance of 10 centimeters, this is not SI unit. Immediately convert it into SI unit, that is 0.1 meters. Calculate the retardation. Now have a look at the alphabets used. There is no time given to you. So without time there is only one formula, and that is third equation of motion. V square is equal to u square plus 2as. Now substituting the values. So that turns out to be 400 plus 0.2a, taking it on the left hand side, it becomes minus 0.2a is equal to 400. Therefore, minus a is 400 upon 0.2, and that's nothing but 2000. The question asked is find acceleration. No, they have asked you calculate the retardation. Minus a is called as retardation. So hence, retardation is 2000. Don't forget to mention the units, meters per second square. Initial velocity of the train is 20 meters per second. It is brought to rest, so v is equal to 0 after applying the brakes, and this happens in 5 seconds. Calculate the retardation. Very simple. V is equal to u plus at. You can directly use a is equal to v minus u by t also. V is equal to u plus at. V is 0, u is 20, a you have to find, time is 5 seconds. So taking 5a on the left hand side becomes minus 5a. So therefore minus a is 4, therefore retardation. They have asked you retardation. So minus a is called as retardation. Hence retardation is 4 meters per second square. A train starts from station A, goes to station B, and then comes back. While going, it travels with the speed of 60 kilometers per hour, and while coming back 80 kilometers per hour. The distance being the same, you can take it as x kilometers, you want to keep it as d, choice is yours, I am taking it as x. Let's find time taken in individual cases, okay, A to B as well as from B to A. Time is distance upon speed, so in this case the time will be distance x upon 80 hours. So total distance is how much? 2x kilometers, and total time 7x upon 240 hours. First part of the question, average speed. Average speed is total distance upon total time. X and x will get cancelled. So you're left with this 480 upon 7, that is 68.57 kilometers per hour. Second part mein they are asking calculate the average velocity of the train, which is equal to displacement upon total time. Since it started from A, went to B, again came back to A, displacement is 0, whatever time it took, hence the average velocity of the train is 0. Not doing the 8th sum, it's similar. Ninth one, car travels a distance of 100 meters. So distance traveled 100 meters with a constant acceleration and average velocity of 20 meters per second. Average velocity given to you 20 meters per second. Final velocity is 25 meters per second. As we all know, average velocity formula when time is not given, u plus v upon 2 also you can write. So this is 20. They have asked you find the initial velocity. V is 25 upon 2. So we can solve this further. So initial velocity is 15 meters per second. Second part, acceleration. Now you have all the values. We can find the acceleration by using third equation of motion. Substituting the values. So 625 minus 225 is equal to 200a. So that is 400 upon 200 is equal to a. Therefore acceleration is 2 meters per second square. Retardation is 25 centimeters per second square. So minus a, or a is equal to minus 25, whatever you can write it as, centimeters per second square. Convert this into meters per second square. You can write 0.25 or 1 by 4 meters per second square. And it takes 20 seconds to stop. Time taken is 20 seconds to stop, means v is equal to 0. Calculate the initial velocity. So substituting the values. So for 5s are, so 0 is equal to u minus 5. I can take it on the other side. 5 is equal to u. Therefore, initial velocity is 5 meters per second. Second part, the distance traveled in the same time. Second equation of motion, substitute the values. You have just found out is 5, time taken is 20 seconds, plus half, acceleration is minus 0.25, and time is again 20 seconds, 20 square. So if you solve this, you get 100 minus 50. So the distance is 50 meters. Body moves from rest, so u is equal to 0 with uniform acceleration and travels 270 meters in 3 seconds. So let's calculate acceleration using second equation of motion, substituting the values. So I can cancel 9 30s, so the acceleration is 60 meters per second square. They have asked you find the velocity of the body after 10 seconds. V is equal to u plus at, and this time is given to you 10 seconds. So V is equal to 0 plus acceleration is 60, time is 10, hence the velocity of the body will be 600 meters per second after 10 seconds. This sum is more of mathematics, less of physics. Let's see. A body moving with constant acceleration travels 3 meters and 8 meters. Two distances have been given to you. So first I'm writing S as 3 meters and second one as 8 meters. S1, S2 also you can write it as. Time given to you is 1 second, and in this case the time given to you is 2 seconds. Calculate the initial velocity and acceleration. So calculate initial velocity and acceleration. S is equal to ut plus half at square. Just substitute the values. 3. We don't know the value of u, time is 1. Half, we don't know the value of a, time is 1. This becomes 3 is equal to u plus a by 2. Multiplying throughout with 2, we get the equation as 6 equals to 2u plus a, and we can mark this as equation 1. Similarly, you can solve for the second equation, same way. S is equal to ut plus half at square. Substitute the values. 8 is equal to, hence we can write 8 is equal to 2u plus 2a, and this is equation 2. Now solving both the equations by simultaneous equation method. If you remember mathematics, you have a chapter. So 2u plus 2a is equal to 8, and the first equation is 2u plus a is equal to 6. So multiplying this equation with 1 and this equation with 2, and then subtract. So 2u plus 2a is equal to 8 as it is. This becomes 4u plus 2a equals to 12. Now subtract. Minus 2u, this gets cancelled, is equal to minus 4. Therefore, u is 2 meters per second. Substitute this value of u in any one of the equations. You can substitute here or here. I am substituting in equation 1. Choice is yours. So equation 1 is 2u plus a is equal to 6. So 4 plus a is equal to 6. Therefore, a is 2 meters per second square. A car travels with a uniform velocity of 25 meters per second. So velocity 25 meters per second for 5 seconds. Uniform velocity. So my question is, after 5 seconds, how much is the velocity? Uniform velocity. So the velocity remains same. आपने acceleration कुछ नहीं किया. 25 meters per second. So let's calculate acceleration. Those who want to, otherwise it is straight away 0, because speed is same, velocity is same. So 25 minus 25 is 0. 0 upon 5, answer is 0. You can write directly also. Acceleration is 0. Okay. Distance to which the car travels before the brakes are applied. You have to calculate the distance. So let us say this is S1 is equal to ut plus half at square. Substitute the values. Since acceleration is 0, so the second part becomes 0. So answer is 125 meters. I'm asking you the same question once again. After 5 seconds now, how much is the speed? Still the speed is how much? 25 meters per second. And now the brakes are applied. And the car comes to rest. V is equal to 0 comes to rest. And this happens in 10 seconds. Now how much is the retardation? Let's calculate the retardation. Substitute the values. Taking 10A on the left hand side, minus 10A is equal to 25. Minus A is 2.5. So therefore, retardation is 2.5 meters per second square. Distance traveled in this particular time, say S2. Again, ut plus half at square. Substitute the values. U is 25, time is 10, plus half multiplied by A is minus 2.5, time square, that is 10 square. Solve this. This is 250 minus 125. So the distance traveled is 125 meters. A spacecraft is flying with initial speed or initial velocity of 75 kilometers per second. And its rocket motors are fired for 6 seconds. And at the end of this time, the velocity achieved is 120 kilometers per second. So it is accelerating. 75, it went to 120. Find the acceleration. Substituting the values, it is 120 minus 75 upon 6. So that's 45 by 6. That is 7.5 kilometers per second square. Now distance traveled in these 6 seconds. Formula is, say, S1 ut plus half at square. Substituting the values, this is I am finding for first 6 seconds. Solving further. So 450 plus 135 is 585 kilometers. This is the distance traveled in 6 seconds. Now the next part. What is the velocity right now? Tell me, of the rocket. It is V is 120 kilometers per second. That was the last velocity we wrote from here. This one. Now this is the initial velocity. Right now the velocity is 120 kilometers per second. And they are saying that find the distance traveled by the spacecraft in first 10 seconds. Now the velocity remains same, no acceleration. 6 seconds are already over. So how many seconds are left? 4 seconds. So let me calculate distance. But before that we need acceleration. No speeding up, 120. So 120 it is. So therefore acceleration is 0. Hence say S2 is equal to ut plus half at square. Substituting the values, 120 into 4 plus 0. So now the distance traveled is 480 kilometers. But they have asked you to calculate the distance traveled in 10 seconds. So how much will it be? It was 585 plus 480. That is 1065 kilometers. A train starts from rest. So u is equal to 0. Accelerates at the rate of 2 meters per second square and time taken is 10 seconds. So how much will be the velocity after time 10 seconds? So v is equal to u plus 80. Substitute the values. Hence velocity is 20 meters per second. It then maintains a constant speed for 200 seconds. Now the velocity is 20 meters per second. For 200 seconds, the speed remains same, 20 meters per second. That means acceleration is 0. Okay. Find the maximum velocity reached. We have already calculated. Second part, the retardation. Okay. After this, the brakes are then applied to the train and it is uniformly retarded and comes to rest in 50 seconds. Now tell me, the speed after 200 seconds is 20 meters per second. Brakes are applied and it comes to rest, and the time taken to come to rest is how many seconds? 50 seconds. Calculate the retardation. So in this region, we'll be calculating retardation by the formula V is equal to U plus AT. Substitute. So therefore, minus A, that is retardation, will be equal to 0.4 meters per second square. So they have asked you retardation, so write retardation. 0.4 meters per second square. Next part. The total distance traveled. So let us calculate distance in these three different parts. These three different parts means 10 seconds, 200 seconds and 50 seconds, one by one. Okay. Say this is S1, which is equal to UT plus half AT square. Substitute the values. So distance once we are getting as 100 meters. Now for the second region, that is distance 2. S2 we can mark it as. Same formula, UT plus half AT square, but this time U is 20, time is 200. And this remaining part becomes 0 because acceleration is 0. So in this case, the answer is 4000 meters. What about this third case? S3. Same formula. So this is 1000 minus 500. Answer is 500 meters. So total distance 100 plus 4000 plus 500, answer is 4600 meters. This is the total distance traveled. Now the average velocity. So average velocity, total distance upon total time. Total time is how much? 10 seconds, 210 plus 50, 260 seconds. So we are going to substitute this, 260 seconds. And that is 17.69 meters per second.